You ever look at the super thick cord for, say, a power tool, and then you look at the tiny little wire for your headphones and just think, what's the deal? Why is one so massive and the other so flimsy? Well, today we're going to unravel that mystery, and I promise we're doing it with zero complicated math. Let's get into it.
I mean, it's one of those things, right? It's hiding in plain sight all over your house. You've got this beefy cord for your refrigerator, maybe your AC unit, and then you have that skinny little thing you use to charge your phone. One feels like it could survive anything. The other, well, not so much. And this isn't just some random design choice. It's absolutely fundamental to how electricity works, both safely and efficiently.
So you can really see the difference here. On one side, you have the thick, sturdy cord built to handle a ton of power. And on the other, a thin, almost delicate cable that's really just designed for a tiny trickle of electricity. So what in the world is going on inside these wires that makes their size so important? Okay, let's think about this not as some big, scary engineering problem, but more like an everyday puzzle. A puzzle that, once you get it, is going to totally change the way you look at every single cord and cable around you.
And look, to solve this puzzle, you don't need a calculator, you don't need any complex physics. All we need is one really simple, powerful analogy that you already get. We're just going to think of electricity as water flowing through a pipe. That's it. That's our key to understanding everything.
Seriously, that's it. Forget about electrons and volts for a minute. Just picture water flowing through a pipe. Once you have that image locked in your head, believe it or not, you're already most of the way to solving our puzzle. And what's so cool is how perfectly this all lines up. The electrical current, that's just the amount of water flowing, gallons per minute. The wire itself, well, that's the pipe. And here's the most important part, resistance. Just think of that as friction, like what happens when a pipe is way too narrow and squeezes that water trying to get through.
So let's talk about that friction, because this is where things start to get heated. Literally. This is the real conflict in our story, and it all happens inside a wire that's just too small for the job it's trying to do.
Just picture it for a second. Imagine you hook up a fire hydrant to a dinky little garden hose. What's going to happen? The hose is going to bulge out, it'll probably get warm to the touch, and there's a ton of pressure and friction, right? The water is fighting to get through. That is the exact same thing that's happening with electricity in a thin wire.
You can think of it as an electrical traffic jam. You're trying to shove way too much current, way too many electrons into this tiny wire. And what happens? You get a massive pileup. The electrons are all bumping and jostling against each other, and all that microscopic friction generates heat. And that heat isn't just wasted energy, it's a real danger sign.
And the result? Well, you can see it perfectly here. A thin wire that's being overloaded wastes a huge amount of energy just creating heat. But a thick wire, it lets that same amount of energy flow right through with very little waste. The whole point is to get power to your appliance, not to accidentally create a tiny, dangerous, and really inefficient space heater.
So how do we solve this electrical traffic jam? It's actually pretty simple. We just build a bigger road. We build a superhighway. And this right here, this is the aha moment. A thin wire is like a slow, congested one-lane country road. You get high friction, it gets hot, and it really limits how much traffic can get through. But a thick wire, that's a wide 8-lane superhighway. Friction is super low, it stays cool, and it allows for a massive, smooth flow of electrical traffic.
So the bottom line is, a thick wire just gives the electricity more room to move. It's just like adding more lanes to a highway. You get less congestion, way less friction, and way less heat. All that power gets delivered right to your fridge or your power tool instead of being wasted as dangerous heat inside the wire itself.
And look, this isn't just some fun little thought experiment, right? Getting this superhighway idea is actually critical for using electricity safely and efficiently in your everyday life.
So what's the big takeaway for you? Well, it all comes down to safety and efficiency. Using the right wire size prevents overheating, which is a major fire hazard. It also makes sure your devices are getting that smooth flow of power they need to run the right way. That's exactly why you always have to match an extension cord to the tool you're using and why you should never, ever plug something like a space heater into a cheap, thin power strip.
So now I want you to just look around you, right now. Look at the cord for your lamp, for your TV, your microwave. Every single one of them is an electrical superhighway that was built for a very specific amount of traffic. They're not just wires anymore, are they? They're telling a story of power, friction, and flow. So what story are they telling you?